Good day everyone. In the last video, you learned a new property. Integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx. And we have done some sums where the integrand is a modulus function which contain either a simple linear algebraic function within the modulus or a combination of 2-3 linear algebraic functions with a plus sign in between or a product of two linear functions. Now today, let us see some trigonometric functions within the modulus. We will be using the same property and solve the sums. Okay? Now look at the three sums. Integral 0 to pi mod cos x dx. Integral 0 to 2 pi mod sin x dx. Integral 0 to pi by 2 mod cos 2x dx. You can use the same criteria like equating what is inside as 0. But here the quadrant also you should remember because it is a trigonometric function. Okay. So now I will do one sum and you can try the other two sums yourself so that you will be thorough with this model. Right. I will take this sum. I is equal to integral 0 to pi by 2 mod cos 2x dx. Let me equate what is inside the modulus to 0. So, cos 2x, that will be equal to 0. You know, cos pi by 2, cos 3 pi by 2, they all will be equal to 0. That is, any odd multiple of pi by 2 will be equal to 0, right? But remember this limit 0 to pi by 2. We need the c in between this a and b because that is the condition. So now I will write this is equal to cos pi by 2. So 2x will be equal to pi by 2. So x will be equal to pi by 4 which lies between that 0 and pi by 2, right? Now let me try cos 3 pi by 2. Now cos 2x is equal to cos 3 pi by 2. So 2x will be equal to 3 pi by 2. So x will be equal to 3 pi by 4. Now this will go beyond that pi by 2 limit. So we will ignore this. So let us stop with this one value. X is equal to pi by 4. So now this interval 0 to pi by 2. In between we have a value pi by 4. So if you draw a number line, this is 0. This is pi by 2. In between you have got pi by 4, right? So now we can write this as integral 0 to pi by 4 mod cos 2x dx, which is my f of x, plus integral pi by 4 to pi by 2 mod cos 2x dx. Now I have to see where this will take a positive value and where this will take, in which interval this will take a negative value. Now, between this 0 to pi by 4, I can take the value pi by 6, correct? If I take pi by 6, what will happen now? You are having cos 2x. So, cos 2 into pi by 6, that gives you cos pi by 3, that is cos 60. That belongs to the first quadrant. Pi by 3 belongs to the first quadrant. So definitely that is positive. So here in this interval, the mod cos 2x will be positive. If you consider this interval pi by 4 to pi by 2, you can take pi by 3. So cos 2x will become cos 2 pi by 3, which is cos 120 degrees. That is second quadrant. Cos theta will be negative. So here you will get a negation. Is it clear? So now in this interval, that is 0 to pi by 4, this modulus will take positive. It will be positive. Here it will be negative. So let me write this is equal to integral 0 to pi by 4. Here it is cos 2x dx. And in this interval pi by 4 to pi by 2, this is minus cos 2x dx, right? Now let us integrate. It is like two integration sums, that's all. When you integrate cos 2x, you will be getting sin 2x divided by 2 within the interval 0 to pi by 4. take this minus here out. So the same thing, sine 2x by 2, this is pi by 4 to pi by 2. So take the 1 by 2 out. Sine 2x means you will get sine pi by 2 which is 1, then minus 0. Then minus 1 by 2 here. If you have pi by 2, it will become sine pi, which will become now 0, right? Then minus sine 2 into pi by 4, that will be sine pi by 2, so that will be equal to 1. So here half into 1 you will get half, here minus into minus will be plus, so the answer is 1. Is it clear? So here as usual equate that to 0, then get the 1 which is in between that interval and then see where it is positive, where it is negative, then do like two integration sums and apply upper limit minus lower limit. Is it clear? Hope now you will be able to do these two sums yourself. Similarly, equating what is within the modulus to 0 and finding the intervals and then proceeding. You have to check the quadrants also. Okay, is it clear? Now, let me move on to the next sum now. See these two sums now. Integral 0 to 3 by 2 mod x cos pi x dx. The next sum, integral minus 1 to 3 by 2 mod x sin pi x dx. In these two sums, within modulus, you have a product of an algebraic function and a trigonometric function. So let us see how to go about this sum. I will do this one, then you are going to do the other one, right? So now, within modulus, you are having x cos pi x. As usual, let us equate that. That is x cos pi x is equal to 0. X can be 0, that is one possible solution. So we can take x is equal to 0. That coincides with the lower limit. Okay? Then the other possibility is cos pi x is equal to 0, which you can take as cos pi by 2. So pi x will be equal to pi by 2. Pi will go. You will get x is equal to 1 by 2. This value lies between that 0 to 3 by 2. Let us check the next one, whether it will come or not. Now I will equate cos pi x is equal to cos 3 pi by 2, because that is also 0, right? So I will get pi x is equal to 3 pi by 2. Pi and pi will go. I get x is equal to 3 by 2. This coincides with the upper limit 3 by 2. So now in my number line where I will have the a as 0, the b as 3 by 2, that one value which is 1 by 2 is coming as the c here. So I get only two intervals. One is 0 to half, the other one is half to 3 by 2, right? Now I have to actually check in which interval this mod x cos pi x is positive and in which interval that is going to be negative. So first let me write the sum. I is equal to integral 0 to 3 by 2 mod x cos pi x dx. This I can write it as 0 to half mod x cos pi x dx plus integral half to 3 by 2 mod x cos pi x dx, right? Now I have to find this modulus function, in which interval it will be positive and in which interval it will be negative. Now, let us come to 0 to half. I can choose 1 by 4 then. If I take 1 by 4, what will happen to x cos pi x? Let us see. X is 1 by 4, so that is positive. Then cos pi into 1 by 4, that is cos pi by 4. That is also positive because pi by 4 belongs to first quadrant. So positive into positive. So the product x cos pi x is positive in this interval 0 to half. Okay. Let us come to the next interval, half to 3 by 2. 1 lies in the interval half to 3 by 2. So if I put 1, x is 1, that is positive. cos pi into 1. So it is cos pi, that is minus 1, that is negative. So positive into negative, the product becomes negative. So here this is negative. Is it clear? So in the first interval it is positive, in the second interval it is negative. This is the way you have to check. So now I will be getting this is equal to integral 0 to half. You will get a positive 1, that is x cos pi x dx, right? Then for the second interval it is negative. I take the negative outside. I will write half to 3 by 2 x cos pi x dx. So in both the integrals, the integrand is the same. Only the limits differ. We have got x cos pi x as the integrand. Here you know x is an algebraic function and cos pi x is a trigonometric function. When you get a product of two different functions, you have to use what method? Integration by parts. So what I am going to do is, I will integrate the x cos pi x dx without considering the limits. I will get what answer it is. Then in the two integrals I will put that result and I will substitute the limits. Okay? Because we are going to get the same integration, I will do it once now. Within bracket I will integrate that part. So here I am going to integrate x cos pi x dx, right? So this we are going to do by the method integration by parts. So here the u function is what? The algebraic function. Use the highlight rule to identify the u function. So u is x. So dv will be cos pi x dx. So you differentiate, you will get du is equal to dx. When you integrate here, you will get v is equal to. When you integrate cos pi x, you will be getting sin pi x by pi. The coefficient of x is pi. This is the v, right? Now let us write the formula. Integral u dv is equal to uv minus integral v du. So here you will get x cos pi x dx, that is equal to u into v. So x sin pi x by pi minus integral v du. So v is sin pi x by pi, then du is dx. Is it okay? So now let us integrate the second part now. In the second part I can take that 1 by pi common. So let me write the first part is x sin pi x by pi minus 1 by pi. Then within bracket, when I integrate sin pi x, I will be getting minus cos pi x by pi. Minus cos pi x by pi. Let me write it properly. X sin pi x by pi. Minus into minus will be plus 1 by pi squared cos pi x. So now, once we integrate that x cos pi x dx, we are getting x sin pi x by pi plus 1 by pi squared cos pi x. Is this clear to you? So now, this result, that is what we have integrated, this one, we are going to apply here within the limits. For the first integral it is 0 to half. For the second integral it is half to 3 by 2. We will apply there. We will apply upper limit minus lower limit and then we will solve the problem. Okay? So now we have integrated this and that result for the first integral, it will be within the limits 0 to half. The same result here within the limits half to 3 by 2. So now we have to just apply upper limit minus lower limit for each term. Let us do it carefully. So here for the first one, let us take 1 by pi common. Okay, I am having x sin pi x. When I substitute half, I will be getting half, then sine pi by 2. Then the lower limit, when I substitute 0, that will become 0. So now that will be 0. This is the first one. Coming to that part, it is plus 1 by pi squared into cos pi into half. So it is cos pi by 2 minus cos 0. This is the second term. Okay. Then there is one minus that will apply for both. So minus 1 by pi. You have got x sin pi x. First the upper limit will be 3 by 2 sin 3 pi by 2. Okay. Minus the lower limit 1 by 2 sin pi by 2. Coming to the next term, that is also minus 1 by pi squared into cos 3 pi by 2 minus cos pi by 2. Okay. So now let us go term by term. So here it is 1 by pi. Sin pi by 2 is 1. So you will be getting here 1 by pi into 1 by 2. That's all. Because you are having a 0 here. Coming to this one, cos pi by 2 is 0. Cos 0 is 1. You have got a 1 by pi squared here. So you will get minus 1 by pi squared. That is the second term. Coming to the third one, sin 3 pi by 2. That will be minus 1. So you will get minus 3 by 2. Sin pi by 2 is 1. So minus half. So minus 3 by 2 minus half, that will give you minus 2, right? Outside there is a minus. So you will get plus 2 by pi. Okay. Coming to the last term, cos pi by 2 as well as cos 3 pi by 2, both are 0. You know, any odd multiple of pi by 2 is 0. So the fourth term vanishes. So now you are getting actually, it is 1 by 2 pi minus 1 by pi squared plus 2 by pi. Let me take 2 pi squared as LCM. So I have a 2 pi here. So I will get a pi here. Here I have pi squared. So I will get minus 2. Here I have a pi. So 2 pi into 2 I will be getting 4 pi. So it is 5 pi minus 2 by 2 pi squared is the answer for this sum. Actually, you have to do it carefully. For each term, you have to substitute upper limit minus lower limit, and you should be familiar with all the values. Okay? Then you are getting this answer. Is this sum clear? Now, you use the same principle, same method, and you do this sum. Integral minus 1 to 3 by 2 mod x sin pi x. Then definitely these two sums will be very clear to you. Okay. For greatest integer function also, if that is the integrand, we will be using this property only. I will just take one simple sum and explain. Let us not go deep into it. Okay. Only one sum I will teach you. I is equal to integral 0 to 3 greatest integer x dx. First of all, before going into the sum, let me just recapitulate what is a greatest integer function. Okay. Now, if you consider an integer, it is very easy. That is, like greatest integer function 2 means it is 2, right? Greatest integer function 3 means it is 3. Because it is already an integer, you get that value. Supposing you have 1.5. Here, the integral part is 1, isn't it? So, the greatest integer function 1.5 will be only 1. If it is 1.99 also, that will be equal to only 1. If it is 2.01, that will become 2. Okay. So, when in the greatest integer, if you have a positive, it is very easy for you. to find out the greatest integer. Supposing it is a negation. Okay. Now, if you have minus 1.5, then actually here the integral part here is that minus 1. You have to remember the number line always. Now, this is 0, this is minus 1, this is minus 2. Okay. So, minus 1.5 will be here. So, what will be the greatest integer? You have to go this side to the left of. So, minus 2. So, minus 2 will be the greatest integer here. Okay. So, whenever you have a negation, minus 3.7 means that will be minus 4. So, remember this. This is the principle of greatest integer. Okay. Now, let me come to this sum. Here I have integral 0 to 3 and the greatest integer function I have taken a very simple one, just x there, and you know this limit that is also for x. So, this sum is the simplest possible. So, here from this 0 to 3, what are all the possible integral values of x? 0, 1, 2, then 3. That is both the limits. And in between, or again, let us go to the number line. This is 0, 3. The integral values possible are here 1 and 2. That means I will be now getting 3 intervals. That is 0 to 1, 1 to 2 and 2 to 3. Right? So, let me use this property and I will write it. Integral 0 to 1 greatest integer function dx plus integral 1 to 2 greatest integer function dx. Then integral 2 to 3 greatest integer function x dx. Okay. So, this I can split like this. It depends on the limits, how many intervals you get. Okay. Now, when you consider 0 to 1, here if you consider whatever you choose here, 0 will be the greatest integer. Right. So, here actually for the first one you will be getting 0 dx. When you consider 1 to 2, whatever you get before that, the left off, that is 1. So, you will be actually getting here 1 dx. The greatest integer value will be only 1 here. Similarly, when you come here from this is 2 will be the greatest integer. That is from 2 to 3, whatever you consider, 2.1, 2.2, 2.4, 5, 2.9, etc. 2 will be the greatest integer. So, here from 2 to 3, this will be 2 dx. Do you understand? So, now for this first part, because it is 0, you will get only 0, I am leaving it. Here I will be actually getting, I will write 0. Here 1 dx, so I will get x within the limit 1 to 2. Here I have a 2 dx, so I will get 2x between the limits 2 to 3. Okay. So, now this bracket is not greatest integer bracket. This is normally we will put a bracket and upper limit, lower limit, that one. So, now I will get here 2 minus 1 for the first one and 2 into 3 minus 2 for the second one. This is 1. So, this is 1 into 2, that is 2. So, the answer here you will be getting is 3. So, this one sum I am just teaching you so that you should know how to integrate a greatest integer function. I am not going deep into it, since actually as per the NCERT book, they have not given any sum based on it. So, I am just stopping it here. So, now mainly you have learned the property integral a to b f of x dx is equal to integral a to c f of x dx plus integral c to b f of x dx is used for modulus functions, where the integrand is a modulus function. I hope all the models are clear to you. In the next video, we will see another new property and sums based on that. Thanks for watching the video. Share it with your friends and classmates. Thank you.